We're going to look at factoring today. So our lesson today is on factoring. When we're factoring, what we're trying to do is we're trying to get things so that they are multiplication. So what factors are is that we're multiplying things together. So for instance, we might have something that looks like this, 3x times x plus 2. So we like that. That's in factored form because it's 3x times this binomial here. See, there's two terms, binomial. So monomial times a binomial. That's in factored form. We also like this sort of factored form. So say x plus 3 times 2x minus 1. So that's factored form. So there's factored form basically just means we're trying to get things so there's multiplication between things. These are two very common factored form that we're going to look at this year. So we've got a monomial times a binomial, or it could be a monomial times, so say 4, and you can have even a trinomial, something like that. Okay, anything like that. So we have monomials times something, two binomials. We might even have a number in front of these two binomials. So it could be something like x or a monomial. So it could be 2x minus 5, 4x plus 1, something like that. So these are all called factored form. So this is factored form. Factored form. So factor, the word factor means to multiply. So we have 3x times the x plus 2, x plus 3 times the 2x minus 1, 4 times that trinomial, x times this times this. So factored form means we're trying to get it into multiplication. So where have we seen this before? So we've seen this when we were doing the distributive property. So we've learned distributive property. Distributive property. Then we were doing things like, say, 3x times x plus 2, where we were distributing in. And then we would have, 3x squared. Sorry, so 3x squared, that's my mistake. I don't have, I'll take that away. So 3x squared plus 6x. So what we're asking you to do now is to be able to work backwards. So we're going to give you this part, and get you to go into factored form. So what we started with earlier in this chapter was that we were distributing in. Now I'm going to give you this part, and I want you to change it to factored form. So this is the factored form. That's what we're aiming for. So we're going backwards. Now, so this one we can kind of look and we say, okay, we have a common 3 in both, and we have an x in both. So that's what we took out, the common factor. So this is called common factoring, and that's the first one we're going to start with in a minute. So that's the first one here. So let's look at this common factoring. So this section here, we're going to look at common factoring. So common factoring is when you're looking for the biggest factor, the largest possible factor. Let me just zoom in a little bit there. There we go. So what we're looking for is exactly what I'm talking about here. So we're going backwards. So here we did distributive property, but now we want to go backwards and we want to go factored form. So you look into each one of the terms, however many terms there are, and see what's common in all of them. That's why it's called common factoring. And we're looking for the largest. So it's a common factor and the largest factors that we can get. So when we look here, we say, okay, 4 and a 3, there's nothing common about those two numbers. But the x's, there's two x's here and there's one x here. So what's common between them is that there's an x. We can take out one x for both of those terms. If I take out one x, you're dividing it by x, you're taking it out. 4x squared, if I take away one x, I'm left with 4x left. One x left, I took one out. Here, I take out the x here, divide it by x, and I'm left with just a 3, minus 3, because I took that x out. I divided by x. That's it. When I say check here, that means that if you wanted to, you could go backwards and use distributive property and go, well, if I multiplied it out, that would get me 4x times x, so it's 4x squared, so 2x is back, and 3 times the x would get me negative 3x. So you can see that's it. You don't have to check. The things I put in this bubble are things that we're just thinking our brain is doing, and you don't have to do it because the question says factor. So the question says to factor. This is just me double checking that, yeah, that makes sense. Okay, so you don't have to do that. In the bubble and stuff we don't have to do, I'm just showing you on the side. So we're looking here again, and we're saying, what's the same between these terms? So there's a 5 and a 10, so I do see that there's a 5 that both of them have. There's m cubed here, but there's no m's here, so I can only take out a 5. I want what's common, the same, between both of those terms. So if I divide it by 5, the 5 is gone, so it becomes a 1. I'm left with 3. If I do 10 divided by 5, I'm left with 2. And that's it. So I took out as much as I could. I look at what's left over and say, is there anything else I could have taken out of both of those terms? And no, there isn't. So then I try it again. So between these two terms, I look at the numbers and I go 6 and 3. What's common, a common factor, is 3. Okay, so I take out the common factor of 3, and I say, okay, is there anything more I can take out? And there's an x, and there's x squared. So both of them have a common x, one x between the two of them. So each one have an x. This one has 2, that one has 1, so I can only take out 1. You want what's the same for both. So I'm going to say, okay, well, I have a 2 left over. 6 divided by 3 is 2. I took out the x, so it's all gone. And here, 3 divided by 3 is 1. So do I need to put the 1 there? You can, but I'm not going to put it because, look, x squared and x, I only have an x left. So you don't want to put the invisible 1 there. I don't need it. Okay, so I don't need it there because it's already a 1x, which we assume is the invisible 1. Okay, check that again. 3x times x would be 3x squared. So that's perfect. And there's nothing left there I can take out. Trying it again. We've got 8x and 4. What's the common number? Common factor would be 4. Any x's I can take out? Nope. This one has only one x. That one has none, so I can't take out a common number. So then here you go, okay, I've got 2. 8 divided by 4 is 2. I have an x left over. Now here, if I do 4 divided by 4, I'm going to get minus 1. So here I was saying, do I need to write the 1? I don't, because there's an x. Here I do have to write the 1, because otherwise there's nothing left over, and it would just be minus blank. So here I do need to write the 1. Here I didn't need to write the 1 because there was already an x there, so you assume that there's an invisible 1. If you write the invisible 1, we ask that you erase it because it's bad form to write an extra 1 that you didn't need it. Here we did need the 1, so yes, we did need the 1, otherwise it would be blank there. So we do need the 1 there. Okay, so that's 4 divided by 4, so it's 1, and since there was nothing else there, I had to write the 1. Does it only work with 2 terms? No. Here I've got 3 terms. I can do more. I can do 5 terms. I can do 10 terms. Just gets a little longer. So you're looking here again. Between these 3 terms, what's the common number? I have 12, 8, and 4. 12, 8, and 4. The common number I would get would be 4, right? Common factor. And then A, I have an A in all of them, so let's say they all have an A. I have a B, C, and D. Oh, so those are not common because I don't have a B, C, and D. So it's common between all 3 terms. So you put a bracket. What's left over? 12 divided by 4 is 3. I took away the A, so it's out here now. I'll have a leftover B. I copy the signs the way they are, so it's going to be plus 8 divided by 4, so 2. A I took out here, and so I have a C left over. Here, negative 4 divided by 4 is negative 1. Now you can think about whether or not you need that, or if you don't have to write it. So if you want, you can put a placeholder 1 for now and say, okay, do I need the 1? And then I go, A came out here, so I took out the common A, and then I have a D left over. So do I need the 1? I don't. So you can go back and erase that guy and say, I don't need that 1 there because I have a D. And then I look at what's left over and see if there's anything else common that I forgot to take out. There's nothing else the same in those 3 terms. My check, again, is optional unless it says to check. I'm just showing you that it works. So here, my check, so this is just your brain thinking, What happens? Why does this work? And it works because of this. So we're going to say this one times this, so 4a times 3b is 12ab. 4a times 2c would be 8ac, AC. 4a times negative b would be negative 4, and then AD. So see how it goes back to the beginning. So that's just my check. I don't want you doing that unless you're just checking something. That's really the only reason. You don't have to do that, but I was just proving to you that it does work, right? So factoring is the opposite of the distributive property. You bring it back out, the common factor. Okay, let's try it again. I did 3 terms again. Remember, you can do more than 3 terms. We just did 3 because, after 3 it starts to get a bit long, but you can do it for as many terms as you want. So you always look to see what's common. So the common number, 8, 6, and 4. 8, 6, and 4, and I would get a common 3, 2. So 2. How many x's? I have 3 x's in this term. I have 2 x's in this, and 2 in this one. So what's common is that they all have 2 x's. How about y's? I have no y's, 2 y's, and 1 y, but since this one has no y's, no, it's not common. It's not the same for all 3 terms. So for the bracket, 8 divided by 2 would be 4. If I took away x squared from the x cubed, so x cubed divided by x squared, I have 1x left. Here, 6 divided by the 2 gives me negative 3. Remember the sign. X squared, I took the whole thing out, and I'm left with y squared. 4 divided by the 2, so I get a plus 2. And then x squared comes out here, and I have a y left. So you can see there's still the 3 terms. You can see 3 terms. When I did distributive, still 3 terms. 1, 2, 3, the common factors. So it's still 3 terms. Nothing else to be taken out, and we're done. Okay, let's try it a couple more times. So at this point, sometimes if you're watching the video, you can pause and you can say, okay, I'm going to pause it. I'm going to try these. This is the try now moment. So you try these, pause me, and then look back to see if you got the right answer. So we're going to try this. I'm going to go ahead and do it, but you can pause the video and you can always go back and try. So you try it yourself while I'm working, and pause me, and then you can go, okay, what have I got that's common between these? I know 3 is the same common number for all. I have 4 x's, 3 x's, 2, so I know I can take out 2. Nothing else, so close it. And we're going to get 6 divided by 3, so it's 2. If I took out 2 x's here, so x4 divided by x squared, I have 2 left. Here, negative 3 divided by 3 is negative, and again, you can do a placeholder of 1 for a minute if you want, and say I'm going to wait, but then I have 1 x left over, so I have an x, so then I would erase this placeholder. I don't need that invisible 1 in front. And then plus, and you don't have to do the placeholder, just in case you're confused as to where I put the 1 or not. So 9 divided by 3, so 3, and I took away the x squared, so nothing left. Okay, that's actually a trinomial. We're going to learn how to factor those in a minute, the next section. Okay, so we'll come back to that in a bit. But that's all we can do for now. All we have is common factors. So the next one, so the next one here, I'm just going to put a line here. Okay, so again, 12, 8, and negative 6. So I know I can take out a 2. 2 is common. So 12, 8, and 6. M, I have 3, 1, and 2. So the most I can take out is 1 from all of them. Right? You want it to be the same for all. N, I have 1, 4, and 3. So I'll take out 1. And then let's write what's left over. And there should be 3 terms left over. So 12 divided by 2 is 6. I have 1, 2 m's left. I have no n's left because I took that one out. Positive 8 divided by 2 is plus 4. I took out the m, so that one's all gone. And I have 4 n's, 1 n is gone, so I have 3 left. Negative 6 divided by negative 2 is negative 3. I had 2 m's. I took away 1, so I have 1 m left. M cubed, I took away 1, so n squared. N cubed, sorry. Look here, 6, 4, and 3, nothing's common. I have no m's common, so we're all good. try the next example. This is called binomial common factors. So what we were doing here was a monomial common factor. So coming back to this word, I didn't specify that earlier, but a monomial means a single term. So these guys here are all monomials. So monomial, monomial. So those are one term. So we took out these one terms here. That's a monomial common factor. So on the next page, we're going to look at binomial common factor. Pausing the video.